Hi everyone, I'm Michal Armoni, and I will present our work, Framework for a Reservoir of PCK Segments of K-12 Computer Science Teachers. A short reminder about PCK. This is a major component in a teacher's knowledge, the one that encapsulates the teacher's unique expertise. Using Schulman's original words, it contains the most powerful analogies, illustrations, examples, explanations, and demonstrations, the ways of representing and formulating the subject that make it comprehensible to others. Namely, this special knowledge is the professional knowledge that links between a specific content knowledge, such as computer science or biology or history, and the pedagogical knowledge, including the best procedures of teaching the specific content in order to maximize the learning outcomes. PCK is personal. It is rooted in the teacher's practical experience, and therefore it is different from one teacher to another, reflecting the teacher's preferences, teaching style, etc. That is, there is no one body of ideal PCK which every teacher should possess. Nevertheless, PCK has been shown to be transferable, and since it has also been shown to improve students' learning, it can be used to train teachers. Hence, it plays a significant role in pre-service teachers' training, as well as in-service teachers' professional development processes and in developing teaching materials. Teachers can then personalize such externally imported PCK by adopting and adapting it to become their own. To support that, resources of PCK are needed. And this is our goal, to devise a framework for such a reservoir. Efforts have been made in several educational projects to create resources of PCK for teachers, and they are reported in the literature. Several of those are discussed in the paper, and this is a partial list. They are certainly very good and valuable resources for teachers. Due to the time limitations, I will not elaborate on them now. I will just say that we are aiming at something different. We want the reservoir to consist of complete segments, which the teachers can easily incorporate into their class practice or use. For example, it will not contain general tips or guidelines or complete course portfolios. It can contain such as a suggestion for a deductive strategy that aims at handling a specific problem, such as known difficulties, and has been proven to achieve its goals. Or, for example, it can contain known misconceptions. It is an explicit PCK segment. If it is a lesson, it should be made clear what PCK needs it addresses. And we insist that every segment is rooted in teaching practice, something that the teacher has done or that was found in authentic teaching situations, and that every segment is reliable, supported by research, following Schulman's vision. The last requirement may seem very strong, but it is feasible. First, research literature on computer science education can serve as a valuable source for known results, such as misconceptions or effective teaching strategies. Second, in a previous study presented in last ETC, we have shown how action research can be used effectively to obtain authentic research-based PCK segments of CS teachers. Our reservoir has no clear shape, such as a matrix of some sort. For example, like the decompositional structure suggested by Hugwizir, which has two dimensions: different activities that the teacher should know how to perform, planning and design, reacting online on students' demands, evaluation, in different contexts. There are 15 rows, each composed of sub-rows. There are just two examples here from the 15 rows: learning content and curricula and standards. A compartmental structure, such as a matrix, assumes an ideal body of PCK that is dissected into pieces according to some preset dimensions. A coherent self-contained PCK segment, such as a specific didactic strategy, will have to be cut to small pieces to fit into different compartments. It is more suitable for assessing teachers' PCK. Me, as I mentioned before, refer to PCK as an ever-growing personalized body of knowledge. Therefore, a compositional amorphic structure is more appropriate. And just like a real body of knowledge, which resides in the human brain, it is not composed of isolated segments. There are links between segments, and when a new segment is added, new links are created to already existing segments. It is well known that the effectiveness of knowledge structures in our brain greatly depends on their connectivity. High connectivity enables using a piece of knowledge in various contexts. Thus, a reservoir is actually a graph, where segments are linked by tagged edges that stand for connections. For example, here is a PCK segment obtained from a study by Gelezer and Tzu which presented 4 misconceptions of high school students regarding the concept of algorithmic efficiency. They are research-based and were found in authentic teaching in high school. The longer a program is, the less efficient it is. The more variables a program has, the less efficient it is. Programs that contain the same statements in different order are equally efficient, and programs that perform the same task are equally efficient. Once added, this PCK segment can be connected to other segments through tagged edges. Just a few examples. Edges tagged with misconceptions will enable teachers to be reminded of this segment when they see another segment dealing with misconceptions, or the other way around, instruct other segments dealing with misconceptions when reading this segment. Some of the misconceptions in this segment stem from difficulties with abstraction or from the unconscious use of an intuitive rule. These are 2 other connections that may prove beneficial to a teacher that may want to use this segment. Other straightforward links would be, for example, efficiency or introductory CS. When a user of the reservoir chooses to follow a tag, it leads to other segments that have the same tag in their tag list. So in general, the segment is composed of descriptional fields containing important information on the segment, its content, and links to other segments. The collection of all segments represent a graph, where for each segment, the first 2 components represent the node, and the third component represents the edges, where a tag represents multiple edges to all nodes that share this tag. Note the 2 nodes can be connected by more than one edge, but parallel edges have different tags. We were working towards a saturated set of fields and tags. Based on our experience as researchers and teacher educators, we started with an initial list. We augmented this list by extracting additional fields and tags from literature on CS-PCK using content analysis. Then we turned to research publications on CS students learning, such as the one by Galezer and Tzu on efficiency, again using context analysis, to find additional tags and fields until we reached saturation. Finally, we turned to our set of PCK segments obtained through action research in our previous study. Just a quick look at another segment to see how the first 2 parts may look. This is a PCK segment obtained from a research by Haberman and Kolikon Ben David, presenting a method for overcoming difficulties of 10th grade students when introduced to the basic algorithmic concepts. Not all fields are fully described here for obvious reasons. Students' age was 16 and they were at 10th grade. It was taken, just as I said, from a paper by Haberman and Kolikon Ben David from 2001, and the study was conducted in Israel. The curricular context is Introduction to CS, and it concerns the concepts input, output statements, variables, assignments, and a few more. It does not assume any previous knowledge, since these are the very first lessons. It refers to an imperative core, and the programming language can hence be flexible. It is intended to overcome students' difficulties and misconceptions when studying these concepts. Instructional strategies exploited in this study were the use of black boxes and lab first lessons. A fundamental CS idea that is mentioned in this segment is abstraction, and whoever is involved with adding this segment to the reservoir will use the following keywords, in this case variables, misconceptions, input, output, and more, and may add general comments. Then comes the content. Full description given here only partially. In a 1.5-hour lab session, students were introduced to basic concepts by using black boxes. They solved hands-on tasks while conversing with the computer using black boxes for input, output, and assignment without any previous knowledge of syntax, etc. Included resources are lab activities and non-validated diagnostic post-test. This is important. The test was used in the study as a validated research tool. However, it was not validated as an assessment tool for teachers who may want to use it for this purpose. I hope these 10 minutes were enough to give you a flavor of our framework. We are aiming at a reservoir that enjoys the advantages of highly connected knowledge structures. It constantly grows, and new segments are connected to older ones according to their characteristic and attributes. We insist on segments that are reliable and authentic and are ready to use after the necessary personalization. Thank you.